Can You Filter Your Water by Brittany Evans. First, I gathered the materials we were sent in the mail and the other materials. I gathered tacks after watching the video Water Science Water Filtration Activity and looking at the images in the article Engineering Encounters. I gathered coffee filters, a rubber band, and cups with pre-made holes because I had them from a previous science experiment. I would have made smaller holes if I would repeat the experiment again, but I'll discuss more about that as I attempted to overcome this issue during my second and third trials. First, I did some research and I watched the video clips. I learned that it is important to stir the alum and let it sit based on the Southwest Backpacker clip. I also found it fascinating how the flocculants group with the colloids to increase their weight in the MIT K-12 videos, and then I was able to see it in action during our investigation. I also needed to determine what materials compare with the Earth's layers. I base this on my personal knowledge gleaned from my sister, who is an environmentalist and has made it her mission to bestow me with a wealth of earth knowledge on our hiking endeavors. I also used the Water Science Water Filtration Activity clip and the Engineering Encounters article. I came up with the idea of using cheesecloth for the humus, charcoal for the topsoil, sand for the subsoil, and gravel for the fragmented rock. First, I started by collecting some muddy water from my backyard after a rainstorm. I decided to add the alum to the muddy water, just like they did in the video clip, the Southwest Backpacker. I just stirred it and then waited 25 minutes. I was completely impressed with how clear my water became just by adding the alum. During my first attempt, I used the original holes in the cups solely. I realized that the water came out as a dark black hue from the charcoal. I think the two holes appeared to be pitting and disturbing the layers due to an uneven flow, which I had read about in my research for clean water for Haiti. They had developed a biosand filter that uses a diffuser basin to spread the water out evenly across the layers of sand, and I definitely had an uneven disbursement of the water. This led me to, how can I make an even flow? During my attempt 2, I used the original cup holes plus pinholes. I thought that would help spread the flow of the water. After completing this attempt, I realized that the water was still a black hue, but less. So this time I asked, how can I decrease the impact of the large holes in the cup? So for attempt 3, I used the original holes, pinholes, and coffee filters. I thought that might help lessen the flow out of the two larger holes. I also decided to increase the amount of sand because in the biosand filter described by the Clean Water for Haiti, they noted the importance of the depth of the sand with its ability to clean the water. As you can see from my 3 trials, trial 3 appears to be the most clear. Whether this was due to lessening the impact of large holes or the increased supply of sand, I'm not sure, but it still appears clearer than my other 2 trials. When looking at the inquiry continuum, in the first aspect, learners are engaged in scientifically oriented questions. I found that in Engineering Encounters, the first question lacks scientific content and was provided by the teacher, while the second question required scientific reasoning. It was once again teacher imposed. Is there a natural filter that you could look to in order to help you build a more effective filter? This teacher-guided question, however, did allow the students to pose new questions, myself included. When looking at the second aspect, learners give priority to evidence, which allows them to develop and evaluate explanations that address scientifically oriented questions. The learners did independently collect the data, but they were directed as to what data was being collected, water clarity. In the third aspect, learners formulate explanations from evidence to address scientifically oriented questions. The conversation and models were led by the teachers on the Earth's components, and then they were given the materials. But the students were left to formulate explanations following the experiment, which materials related with the Earth's layers. For the fourth component, learners evaluate their explanations in light of alternative explanations, particularly those reflecting scientific understanding. In Engineering Encounters, their video conference with a California school showed that with further probing, they came to the conclusion that infiltration in drought-affected areas is difficult. The modeling activity took on new meaning for the students as they realized it could be adapted in order to explore different questions about their watershed. The learners were given possible connections, but then the learners directed those connections towards areas and sources of scientific knowledge where they could go in the future with it. Personally, I also went onto a list of several water nonprofits to see what kinds of filtration methods they use in third world countries. So I too went beyond the information given. The fifth aspect, where learners communicate and justify their proposed explanations, we find through Engineering Encounters that the expectation was that the students could explain not only the way their filter worked, but how it was an accurate model of the Earth's filtration system. As an elementary teacher, I believe the learners were probably coached in the development of their communication, but the students probably ultimately came up with their own thoughts. Thank you for listening. I appreciate